So you'll notice now this slightly modified spreadsheet from before. So what I've added here in column C are a set of so-called observations along our transect from x20 to minus 20 kilometers. So imagine that you traveled along this traverse, and over these 10 or so positions you measured the Bouguer gravity in milligauss at these different x positions, and the dark blue dots represent those measurements. So this is the measured Bouguer gravity anomaly along that transect. And what we want to try and do is see if we can use our spherical model to predict, or estimate rather, the size and kind of rock, object or body that might be causing this positive gravity anomaly. So what I've done is plotted a simple XY graph where I've plotted the observed gravity, so the observations from column C on the y-axis versus the x position, and likewise for the red line I've plotted the predicted gravity values, so the values predicted by this model which are stored in column B. I've plotted those against x distance as the red line. So the current model is for a spherical object with a radius of 4 kilometers at a depth of 6 kilometers, so fairly deep in the crust but not very deep, and quite a high density contrast. So this del rho of 0.3 would be the equivalent of a gabbro surrounded by granite, for example. So a fairly high density contrast. And if you look at the prediction, it's predicting a similar sort of shape, partly by design of course, but the maximum amplitude is way too high. So our current model has too much mass, or the object is too shallow. So maybe we could change the depth. Now this is where this little table and the way of setting up the variables is quite useful, because what we can do is simply click on this parameter depth, 6,000, and change it. So let's put it deeper, make it 12,000, double it, 12,000 meters, and hit return. And you see immediately the model is updated and the plot is changed, and the only interaction we needed with the spreadsheet was to change one single number. We didn't have to go into our equation, so we didn't have to go into this equation and change depth and then do another pull down for the series. We simply needed to alter the cell value that referred, or depth, the word depth referred to. And that we overdid it a bit, so it's way too low now, so maybe try 8 kilometers or 7,500. Oh, not too bad. It's a bit spiky because the spacings are small here, but you can see that the observed, so-called observed values came from a sphere with approximately these parameters. Okay. And so this little spreadsheet can now be used as a simple model, or modeling tool rather, to try and fit a simple theoretical model to some real observations.